Assalamu alaikum dear students. Today we are going to start a new course, Nuclear Physics 1. In the previous series of Nuclear Physics 1 we discussed different topics of Nuclear Physics 1 in Urdu language for all the Pakistanis and Indian students, but now we start in a new Nuclear Physics 1 series in English for all the students of all the countries. Today, our first lecture of Nuclear Physics 1. Nuclear Physics actually a branch of physics in which we study the nucleus. Simply, you can define Nuclear Physics 1 is a study of the nucleus. And in this course, we learn so many applications of nuclear physics in the daily life and in the medical field, and different instruments which we use in laboratories and in hospitals, laboratories. This is our first lecture. In this lecture, we only define and introduce the nuclear physics and related to the mass of the nuclear mass, types of the nuclei, and nuclear size. Nuclear physics scientists makes a separate branch of physics after the discovery of the radioactivity. 100 years ago, Henry Becquerel discovered the radioactivity, and the discovery of electrons by J.J. Thomson and mass energy balance since 100 years ago, but now scientists make a separate branch and a book of Nuclear Physics 1 and related to all topics and phenomena of nuclear fission, fusion, and so many phenomena in which we explain by the help of nuclear physics. Now students, here is our contents of our first lecture. Firstly, we define nuclear physics. What is nuclear physics? And the study of the nucleus. After that, protons and neutrons. What is the difference between protons and neutrons? Because we study the nucleus, all we know that inside the nucleus, protons and neutrons are present. But outside of the nucleus is electrons. That's why electrons we study electrons shells orbiting in the atomic and molecular physics, but in the nuclear physics we study inside the nucleus protons and neutrons and related to forces of between the protons and the neutrons. Examples of the nuclei, types of the nuclei, how many types of nuclei, and also the nuclear mass defect, what is mass defect, and the size, nuclear size. In the last one, features of nuclear forces, because in nuclear physics the most important is the nuclear forces. All the nuclear forces reactions and phenomena mostly depend on the nuclear forces and nature of the nuclear forces, properties of the nuclear forces. And in the last we saw reference books related to the nuclear physics. Now here is defined nuclear physics in two different branches. Nuclear physics is the theoretically nuclear physics we may explain it theoretically and also for experiment. You can say that nuclear physics is defined into two main categories. One is theoretical nuclear physics and the other is experimental nuclear physics. In theoretical nuclear physics, this is the we explain this course in Nuclear Physics 1, but in semester wise divided Nuclear Physics 1 and Nuclear Physics 2 course. Some theoretically and experimental terms we discuss and explain in Nuclear Physics 1 course, and some explain in Nuclear Physics 2 course. And here I talk to about what topics are discussed in this course of Nuclear Physics 1. Now, in theoretically nuclear physics, the main topics is nuclear properties. What are nuclear properties? nuclear property is basically related to the nucleus. For example, size of the nucleus, mass of the nucleus, charge of the nucleus. For example, inside the nucleus, protons and neutrons all are included in the nucleus, and mass of the nucleus and charge of the nucleus. Protons and neutrons are also say that mass of the nucleus, for example. And also nuclear spin, angular momentum, and magnetic moment, electric dipole moments. All these terms are included in nuclear properties. And then in theoretical nuclear physics are nuclear models. The three main models are discussed in nuclear physics. The models are shell model, collective model, liquid drop model. Firstly, we discuss about liquid drop model. In the liquid drop model, scientists compares the nucleus as a liquid drop and study the atomic semi-atomic mass formula of the and binding energy of the nucleus. No, these models are discussed in nuclear physics too, but nuclear properties are discussed in nuclear physics 1. Now we move the experimental nuclear physics. In experimental nuclear physics, we discuss about the accelerators and detectors, also says counters, some other properties related which are included in theoretical nuclear physics and experimental nuclear physics. For example, radioactivity in theoretical physics, now we speak which terms are included in radioactivity. You can write on your notebooks. And also included in experimental physics are counters, now in radioactivity we study different decays. For example, alpha decay, beta decay, negative beta decay, positron emission, electron capture, inverse beta decays, and gamma decays. Mostly discuss three main decays: alpha, beta, and gamma decays. Now we study in this course alpha, beta, and gamma decays related to the radioactivity. And in experimental physics also included nuclear reactions. But nuclear reaction, now we can write nuclear reaction. Nuclear reactions also explain theoretically and also and experimentally. But we completely explain nuclear reaction in nuclear physics 2 course. In this lecture, we define a course related to nuclear physics 1 and nuclear physics 2, which we study. In nuclear reaction, different types of nuclear reactions related to the mechanism, on the basis of the mechanism, and also different types of nuclear reactions without the mechanism of reactions. Now, in this course, we explain accelerators. Accelerators basically the particles, charged particles, protons and neutrons to accelerate and speed up the reactions, then produce different after our requirements produce different accelerations to speed up to approach the required target, and detectors for the detecting of different uh, used in different instruments, for example diagnosis the disease and tumors. We use and detectors, and also counters or counting rates of these experiments which we perform in laboratories. No, in nuclear physics 1, we explain nuclear properties, radioactivity, accelerators and detectors, and also counters. But nuclear models and nuclear reactions and different other topics, fission and fusion reactions, are explained in nuclear physics 2. Now we start our topic of today topic. Now students, we define nuclear physics. Before defining the nuclear physics, we discuss about the discovery of the nucleus. Students, in the earlier years of 20th century, we know about the structure of the atom and the electrons, which was discovered by J.J. Thomson in 1897. At that time, scientists suggest that the atoms has also have an positive charge inside it, but they cannot confirm, and many questions are arises at that time. Then a scientist Rutherford 1911 was discovered this nucleus. 1911. This is the discovery of nucleus. The scientist is Rutherford. Rutherford nuclear atoms model. He gave an atomic model, atom model, was based on the results of an experiment. They perform an experiment. The experiment is that Rutherford perform an experiment, and they can bombard some alpha particles on the atoms and suggest so many points which can conclude from that experiments. He saw some of the alpha particles should be reflected back and some are absorbed and move in the straight line. Then he thought some of the particle atoms, electrons, why not come back and move straight line, and some come back. They suggest some have heavy mass and some have less mass. That's why the concept of nucleus arises. Then he the concepts of the nucleus. This was the discovery of the nucleus. They perform an experiments and taking different conclusion. For example, the path followed by typical alpha particles, they pass through the atoms of the target foil, and they can take a gold foil and bombarded the atoms on the alpha particles on that foil, and we see that most of them are deflected only slightly or not at all. However, a few of them passing close to the center of the positive charge are deflected through large angles. Rutherford concluded that the dimension of the positive charge concentrated over a region called nucleus must be smaller than the diameter of the atom by a factor of 10 raised to power 4. The diameter of the nucleus must be smaller than 10 raised to power 4 of the atom. The atom is mostly an empty space. Now we define nuclear physics. Nuclear physics is the study of the protons and neutrons at the center of an atom and their interaction. For example, center of an atom is a nucleus, and inside the nucleus we know about protons and neutrons. And in other words, the branch of physics deals with the structure of the atomic nucleus and the radiations from unstable nuclei. Some nucleus are stable and some are unstable. We further know about whose nucleus are stable and whose are not stable. In the next lecture, we make a difference between stable nuclei and unstable nuclei. These are two definitions of nuclear physics. You can write only one of them, and try to write in your own words. Now students, here is a Rutherford golf while experiment. In the previous slide we can take overview of this experiments. Now in this slide we here is a complete setup of this experiments which performed the scientists. In 1911 Rutherford gave a model of the atom. After this model of atom, the other scientists Giger and Marsden initiated a series of ground-breaking experiments that would completely change the accepted model of the atom. The Rutherford performed these experiments. He can take a gold foil and bombarded alpha particles on these foils, then see different results. They bombarded very thin sheets of gold foil with fast moving alpha particles. Here is a gold foil and this is the source of alpha particle, and emitter here emits an alpha particles. They fall on this gold foil and he observed different phenomena. Some of the alpha particles reflected back and some move in the straight line. Alpha particles, a typical nature of radioactive particles, are positively charged particles. We all know about alpha particle is a positive charge particle because it has atomic mass 4 and atomic number 2, and it can also called helium particles. It can represent by He. The atomic mass of the alpha particle is 4 and atomic number is 2. These are the positively charged particles. After that experiments, charged particles with a mass about 4 times that of hydrogen atom. We know that hydrogen has 1 atomic mass and 1 number of protons and atomic number. Alpha particles is 4 times greater than the hydrogen atom. After these experiments, Rutherford concluded different results and give the concepts of nucleus, and then discovered the nucleus because he observed that atom has also inside the atoms has also positively charged particles exist. That's why alpha particles come back repel, because Coulomb's give the concepts of parallel like charges. They can repel each other and the same charge and different charges attract each other. That's why he suggested that the sum of particles having positively heavy particles, they have uh, more atomic mass and some have less atomic mass. That's why they move straight and reflected back. After these experiments, the nucleus discovery observed, and Rutherford said that some of charged particle positively charged exist inside the atom. No, the study of the nucleus. In the previous slide also say that I say that the study of the nucleus is called nuclear physics. No, what is the study of the nucleus? The center of every atom. Students, it means center of every atom. You all know atom is a very small. It means inside the atom is also a small terms which is called nucleus, and it is also called the center of every atom is called nucleus. And the nucleus consists of, and also say that nucleus contains number of protons and neutrons, which is called nucleons. And in other words, a nucleus consists of nucleons, which comprises of protons and neutrons. For example, we can write in the form of formula nucleons, which is equal to protons and neutrons. Nucleons denote by a capital letter N, but number of neutrons always write in small letter. Proton plus neutrons, which is equal to nucleons. And sometimes nucleons we say that atomic mass, which represents by A. In the further lectures, we show atomic mass, which is equal to number of nucleons and which is equal to number of protons plus number of neutrons in every atom. Here is a shell atom. This sphere shows the atom, and red sphere shows the nucleus. But inside the nucleus, here is protons and neutrons. Protons and neutrons are subatomic particles, and fundamental particles, also say that fundamental particles, but many other particles inside the nucleus, which we study further in nuclear physics, in different phenomena and different techniques. Now we define proton and neutron. After the discovery of nucleus, we define proton and neutron because inside the nucleus proton and neutrons are exist. Firstly, proton. Proton basically are subatomic particles inside a nucleus and having positive charge of magnitude 1.6 into 10 raised to power minus 19 coulomb. The mass of proton is 1.673 into 10 raised to power minus 27 kilogram or 1.007276 U. Students, to writing the mass of the proton and magnitude charge, positive charge of the magnitude of the proton is here because this is we can use in different numericals these values, and you can remember these values of atomic mass and charge number of the protons and the neutrons, because sometimes these values are given in the problems and sometimes not given, because this is the basic particles and the values of this mass and charge is fixed. That's why could not be given in the numericals. Now you remember all these values of these particles. The proton is spin half particle composed of 2 up quarks and 1 down quarks. What is quark? Quark is also a elementary particle. Fundamental constituents of matter, that's like protons and neutrons. Inside the nucleus, here is proton and neutrons, and also there exists a subatomic particle which is called elementary particle, is called quarks. The proton is made up of 2 up quarks and 1 down quarks. Highlights. It is an MCQ type question, students. You should be remember. Proton made of 2 up quarks and 1 down quarks. Similarly, neutron is opposite to the proton. Neutrons made up of 1 up quarks and 2 down quarks. The basic difference between proton and neutron. The rest mass energy of proton is 938 mega electron volt. This is the rest mass energy of the proton, which can be calculated after the experiments and by the calculation with the help of formula, mass formula. 938. Students, for MCQs type test, NTS and other tests, these are the most important points which is included in proton and neutrons asked in exams. For example, the mass charge number of the protons and mass number of the protons, and protons is made of how many quarks, up and down quarks. That's why this is most important to all of you, for all of you. Neutron. Neutron is also an subatomic particle inside a nucleus having no charge. You all know about in the small little classes. Neutron has no charge. Neutron is also a neutral, but proton has positive charge and electron has negative charge. The mass of neutron is 1.675 and 10 raised to power minus 27 kilogram, or 1.0086 is 5 joule. This is the small unit of the mass, AMU, atomic mass unit, and simply we represent U. Now highlight this mass of the neutron and have no charge, and the neutron spin is 1 by 2 half particles composed of 1 up quarks and 2 down quarks. The rest mass energy of neutron is 939.5 mega electron volt. Now, after knowing the formula of the calculating the binding energy and the mass of the nucleus, you can also calculate this rest mass energy of the protons and the neutron. Now here is the representation of nucleus. The nucleus of an atom is represented by its chemical symbol and chemical name of the atom, which is denoted by capital X. Capital X shows the nucleus, and A is the atomic mass, and Z is the proton number and also called neutron. Proton number and also called charge number or atomic number. For example, nucleus of hydrogen has Z equal to 1 and A is equal to 1. It is written as H11. This is the example of representation. Here X is capital H and 1 is atomic mass of hydrogen and Z is atomic number of the hydrogen. Similarly, for different atomic nuclei, for example, helium nuclei, He, 4 one thing should be remembered, students. The atomic mass here right on the left corner of X and Z. Also you can write on the right corner of the nucleus and base on the atomic number on the base of the nucleus. Both are right way of representation of atomic nuclei. Now here is 4 is the atomic mass A and 2 is the atomic number and also called proton number and charge number. Students, remember that the proton number is represented by Z, and also it is called atomic number and also called charge number of the nucleus, which represented by Z. These are the three names of this atomic number, proton number and charge number. Atomic mass and some other examples. So atomic mass number, which is equal to A, Z plus N. Z is the charge number, atomic number, plus N is the neutron number, which is equal to A. Number of protons, Z represents the number of protons, plus N represents the number of neutrons. A determines the mass of the nucleus. If you determine the number of neutrons, then A minus C, which is equal to N. For example, uranium. The atomic nuclei of uranium, which represents U239 and 92. 239 and also called 35 is famous uranium atomic nuclei, and 92 is the atomic number. Now we find the neutron number. Then you can write N is equal to A minus Z, because Z is plus Z is plus in the neutrons, but if you find neutron, then Z should be subtract from A minus Z. So A is 235 minus Z is equal to 92, which is equal to 143. 143 is the neutron number of the uranium atom. Uranium 235 Now students, from this formula, if in the exams or MCQs type questions given the atomic mass number and proton number, and you can easily find neutron numbers easily. Here is the atomic mass of uranium atom 235 and atomic number 92. So we find N is equal to A minus Z, and we find N is equal to 143 for the uranium atom, A minus Z. Mostly ask this question in MCQs type tests. So you can find any other atomic nuclei, neutron numbers, how many neutron numbers in the atomic nucleus, you can find easily. Now students, examples of the nucleus and isotopes. Hydrogen, atomic mass is 1 and atomic number is also 1. Now you can say that 1 proton, hydrogen having 1 proton and 0 neutron, because atomic mass of hydrogen is 1 minus 1, which is equal to 0, and 0 number of neutrons. So deuterium is also called isotopes of hydrogen. Isotopes means you can define same proton number but different neutrons number, and also define same atomic number, charge number or proton number, but different atomic mass. Now here you can see hydrogen 1 1, hydrogen 1 2, hydrogen 1 3. The proton number is same but different the atomic mass of the hydrogen. That's why we call hydrogen deuterium, tritium. 1 proton, 1 proton, 1 proton, but 0 neutron, 1 neutron and 2 neutron. You can find 2 minus 1, which is equal to 1 number of neutron, 3 minus 1, 2 number of neutrons and 1 proton. These are also called the hydrogen isotopes. Carbon isotopes C6A12, 12 is the atomic mass and 6 is the atomic number or charge number, proton number. The amount of the proton number is same in all these isotopes, but different is the neutron numbers. That's why it is called the isotopes of the carbon. Students, we discuss about the types of a nuclei. What are the types of a nuclei? Two types of nuclei, and further these types should be divided into further two categories. The first is even atomic nuclei and the second is odd atomic nuclei. A represents the atomic. No, first type of nuclei is even atomic nuclei. Even atomic nuclei means even atomic mass number and even atomic number. These nuclei or nucleus are called even atomic nuclei. Odd atomic nuclei means odd atomic mass and odd atomic number is called odd atomic nuclei. Now here we define even atomic nuclei. The nucleus is called even atomic nuclei when it has even mass number. It means even atomic nucleus mean even atomic mass number. For example, C12, Mg24, Si28. These are the atomic nucleus and atomic nuclei and having even atomic mass. C12 means carbon 12. 12 is the atomic mass of the carbon, and magnesium Mg represents the magnesium nuclei and its atomic mass is 24. And silicon is 28 atomic mass. These are the even atomic nuclei. They are further classified as even nuclei or odd nuclei. Now, for remembering these type of nuclei in your mind, you can a trick, and this one the trick. The first letter, first word of this atomic nuclei of this definition is represents the proton number, and the second represents the neutron number. If teacher asks you, you define even nuclei. Its mean proton is also even number and n is also even number. You know proton is the atomic number which represents by Z, and n is the neutron number. So we define if odd nuclei, its mean odd and neutron numbers and odd proton numbers Z. So the definition of even nuclei is the even atomic nuclei in which Z is even and N is even are called even nuclei. For example, even N is the nucleon number. So C6 and 12. C6 and 12. Neutron number 12 minus 6, which is equal to 6. So the atomic nuclei neutron number and so 12 minus 6 mean which is equal to neutron number 12 minus 6. Nucleon is called the atomic nuclei, but here is n represents the neutron number which is equal to A minus Z. So 12 minus 6 which is equal to 6. 12 is also an even number and 6 is also an even number. So helium 4 is the atomic number and 2 is the atomic number, 4 is the atomic mass and nuclear number. 4 minus 2 which is equal to neutron number which is also 6. So these are the examples of even nuclei. Now odd nuclei means proton number is also odd and neutron number is also odd. The even atomic nuclei in which Z is odd and N is odd. are called odd nuclei. For example, 2 is the atomic mass and 1 is the atomic number. 2 minus 1, 1 is also an odd number and 1 is also odd number. Here 1 is represents the Z proton number and 2 minus 1, which is equal to 1. This is the neutron number. And similarly, lithium 6 minus 3, which is equal to 3, A minus C, which is equal to neutron number. So 6 minus 3, which is equal to 3. This is also an odd number. 3 is also an odd number, atomic, and 3 is also, proton number is also odd. So these nuclei are called odd nuclei. Of the atomic nuclei is odd atomic nuclei. The nucleus is called odd atomic nuclei when it has odd mass number. For example, H3, the isotope of hydrogen, tritium, lithium, 7 atomic mass, and chlorine 35. They are further classified as, it means odd atomic nuclei further divided into two categories, even odd nuclei and odd even nuclei. For remembering these types of nuclei, you should remember that even first term denotes the proton number Z and the second represents the neutron number N. Then you can easily define these terms of the nuclei. Even odd nuclei means the proton number is even and the neutron numbers are odd. The odd atomic nuclei in which Z, odd atomic nuclei means the name of the fundamental definition of odd atomic nuclei. This is the type of the odd atomic nuclei in which Z is even and N is odd. Then these are called even odd nuclei. For example, beryllium 9 and 4. 9 is the atomic mass and 4 is the atomic number, proton number, and oxygen 15, 8. 15 atomic mass oxygen is the isotope of the oxygen. No, 9 minus 4, which is equal to 5. 5 is the atomic number, proton number, which is also called proton number. 4 is even, so even, and 9 minus 4, which is equal to 5. 5 is the odd. So N is odd and Z is even. That's why we called even odd nuclei. No, the second term is odd even nuclei. Odd even nuclei mean odd is the proton number Z and even is the neutron number, opposite to the even odd nuclei. Here is the odd atomic nuclei in which Z is odd and N is even, are called odd even nuclei. For example, H31, 3 minus 1, which is equal to 2. 2 is an even number, its mean neutron number is even, and 1 is the atomic number, which is called, these are the types of atomic nuclei. Now students, we define nuclear mass. Nuclear mass is the representation sum of mass number of protons and mass number of neutrons and their atomic number and neutron number. A nucleus consists of Z protons and N neutrons. Let the mass of the nucleus be M, capital M. Always remember, the mass of the nucleus is represented by capital M, not small m. Z and N. Yani, it means atomic mass of the nucleus is the proton number and the neutron number. If the nucleus is assumed to be a simple collection of Z and N neutrons, the mass of the nucleus would be just the sum of the masses of these constituents of nucleons. Nucleons is also called the atomic mass of the nucleus. So the mass formula for the atomic nuclei, which is equal to MAZ, AZ means atomic mass and proton number, which is equal to Z mass proton number multiplied by MP. MP represents the mass of the proton, plus A minus Z, which is equal to neutron number, and multiplied by Mn. Mn is represents the mass of the neutron, and capital N, which is equal to A minus Z, represents the neutron number. It means that, students, if you find the mass of the nucleus, then you should be know about the proton number and the mass of the proton and neutron number of that nuclei and the neutron number. Then you can easily find the mass of the nucleus, where MP and Mn denote respectively the mass of the proton and the neutron. However, a nucleus is not a simple collection of protons and neutrons, but they strongly combine with each other through a strong interaction named the nuclear force. Because the daily life example, for example, if you put two balls in a sphere, then they can strike with each other, and they can strike and attract with each other due to the force exists between them. But similarly, the neutron and proton exist inside the nucleus due to some interaction, strong interaction, which is called nuclear force. Know the nuclear mass. How to define the nuclear mass of any nuclei? At the start of this lecture, we find the formula for the atomic mass, which is equal to A is equal to N plus Z. So if we find A, then Z plus N, which is equal to A. So C6, if you find the nuclear mass of the carbon atom, then number of protons, which is equal to 6, and number of neutrons, you know that 12 minus 6, which is equal to 6. So atomic mass of the carbon atom, which is equal to number of protons plus number of neutrons, which is equal to 6 plus 6. So the atomic mass of the carbon atom is 12. Here is the representation of carbon atom. And green are the number of electrons which is revolve around the nucleus, and but between the nucleus, which is the neutron and protons, which represents neutron on the red color, and blue is the proton number. Mass defect. Mass defect is basically the deficiency of the mass when you can find the mass of the nucleus and what is the difference between the individual masses of the protons and neutrons and the whole mass of the nucleus. This is called the mass defect. Now you can define the mass of a particular atom is always slightly less than the sum of the masses of the individual neutrons, protons and electrons of which the atom consists. If you find the mass of the atom, then you can find individually masses of the neutron, proton and electron. If you find the mass of the nucleus, then you can find individual mass of the neutron and the proton, not electron. Because you know about atom consists of nucleus and proton, neutron and electron, but the nucleus is consist of the nucleus, which is inside the nucleus, protons and neutrons. So this difference of mass of nucleons means mass of the proton number plus mass of the neutrons number in a nucleus, and mass of that nucleus measures experimentally is called the mass defect. It means the whole mass of the nucleus, which is represented by capital M in the previous slide, and the mass of the individual neutron, which is represented by the formula capital M, which is equal to ZMP plus A minus Z into Mn, and individual find mass of the proton number and mass of the neutron numbers is slightly different to the mass of the whole nucleus capital M. So this is the difference. The difference between the mass of the whole nucleus and the individual nucleus is called the mass defect. So if you find the mass and energy of the nuclei, test mass energy, then you can find easily the here we find the energy. Here we find the energy of the electron, the rest mass energy. The formula of rest mass energy is equal to E is equal to mc square according to the Einstein. So E is equal to 1u multiplied by c square. 1u is the atomic mass of the electron and c square is the speed of the light and c square. So 1u is equal to, we all know about 1u is equal to 1.6606 into 10 raised to power minus 27 multiply by 3 into 10 raised to power 8 square. Then E is equal to, put in this formula 1u c square and divided by 1.66 into 10 raised to power minus 19 electron volt, and the energy can be represented in mega electron volt. For converting the energy values into electron volt, so we can divide this whole term by 1.66 into 10 raised to power minus 19. So the formula is E is equal to 931.5 mega electron volt. Now students, write this example on your notebooks, and you should write and calculate on your own hand on this on your copies easily, and also find the rest mass energy of the protons and the neutrons on your notebooks. Nuclear size. The nucleus is the center of an atom. It is made up of nucleons called protons and neutrons. We all know about the nucleus, and is surrounded by the electron cloud. You should also know the electrons are revolving around the nucleus of the atom. The size and diameter of the nucleus is between 1.6 femtometer for a proton is light hydrogen to about 15 femtometer for the heaviest atoms such as uranium. It means that students, the mass of the size of the nucleus is start from 1.6 femtometer, which is equal to 10 raised to power minus 15 meter for lighter nuclei, and further move on the heavier nuclei, then the mass of the size of the nucleus is increasing and go to the 15 femtometer, and 15 femtometer is the size of the nucleus of the uranium atom. So the sizes are much smaller than the size of the atom itself by a factor of about 2300 uranium to about 145,000 hydrogen, 1,45,000 of hydrogen. Although it is only a very small part of the atom, the nucleus has most of the mass. Here is an example of the hydrogen atom and uranium. Know the nuclear forces. The most important in nuclear physics is the nuclear forces, because they exist between the protons and neutrons inside the nucleus. They can also exist between protons and neutrons, neutrons and protons. These are the strong forces. That's why nucleus is stable. If any of the nuclear forces weak, then the nucleus should not be stable. Nuclear forces, also known as nuclear interaction or strong forces, are the forces that act between two or more nucleons. Its main nucleons mean proton and neutron. It exists two, proton and more nucleons, more than two. Features of nuclear forces, also called the properties of nuclear forces. The first one is that nuclear forces are primarily attractive. It means if the forces are non-attractive, then the protons and proton neutrons repel each other, not attract each other. Then the nucleus cannot be stable. That's why the nuclear forces are attractive forces, because nucleus exists in the stable form, and the forces between the neutron and protons are strong. Nuclear forces are non-electric because there is no electric field between the nucleus of the atom, and no attraction between these particles. That's why they and no attraction between nucleus with the earth. That's why it is called non-attractive. Nuclear forces are non-gravitational. The pull of gravitational does not depend on the nuclear forces and do not affect the nuclear forces. That's why nuclear forces are called non-gravitational forces. Nuclear forces are extremely strong. We all know that nuclear forces are strong forces because it exists inside the nucleus between the proton and neutron. The next fifth point is nuclear forces are extremely short range forces, because we know that inside the nucleus is a very small, because atom is a small, but inside the atom nucleus exists. Nucleus is also so small. That's why inside the nucleus proton and neutron, and these forces are exist between the neighboring atom. That's why it is called short range forces. Nuclear forces are charge independent. It does not depend on the charge, because it exists between proton, neutron. Neutron has no charge. Neutron and proton, neutron and neutron. That's why it is independent of charge. Nuclear forces are spin dependent. It depends on the spin, because the particles move and having different spin, proton and neutron. If they change the spin, then nuclear forces should be effective. Nuclear forces have the property of saturation. Property of saturation means nuclear forces exist and act on the neighboring atoms, only neighboring atoms. For example, proton and neutrons. These are all the properties of the nuclear forces. Now today our lecture is end. No students, today lectures is very informative. If you can take interest, then you can easily understand and get some knowledge and information related to the nuclear physics introduction. If you have any problem, then you can ask me on the comment box. I hope so you can learn more regarding to the nuclear physics. No, in the next lecture we can study some other nuclear properties, and if you in this lecture if you have any problem, then you can ask me on the comment box and in the classroom. So Allah Hafiz students, thank you so much.